Welcome to the 2017 Section C question, Geological Geometry. It's question C1. The accompanying map, so here's our map that comes with our paper, located in the back of Section A, that's fine, and it's a ski run. Okay, the map ABCD is the centre line of the ski run. So here's our ski run ABCD. The ski run has the following specifications. So from A to B, it's level at an altitude of 65. So we're at 65 here, and we're at 65 here. Okay. Portion of the ski run from B to C is falling uniformly, so it's sloping down to a level of 50 at C. So at C here, we're at 50. Then portion of the ski run from C to D is level at an altitude of 50. So C running through to D here is at 50 again. Okay, so level, sloping down, level off again. Using slope, side slopes of 1:5 for cutting. So we've got our cut is to 1 is to 1.5, and our embankments, or our fill, is 1 is to 2. Complete the necessary earthworks for ski run between A and D on the northern side. You may ignore the southern side. So northern side, so we're just dealing with this side. We can ignore down here. So looking at our intervals, we've got 5-meter intervals. So with our cut cone, and cutting into the hill, we're going up 5, so we're going 7.5 into it. Okay, and that's our level there. Okay, so we need to go 7.5 millimeter intervals. This is best I can to measure 7.5. So 50, halfway, 7.5. 7.5. Okay, so at a level 65, so we're going to have cuts. So that's 65, 70, 75, 80, 85, and also 90. So they're the heights that I need. Okay, there's nothing above that, so we can come along here to my 70s, actually right on that. Then we've got 75, 80, 85, 90, and 90 again. Okay, so that should do us as far as B. If we need to, we can always extend on to find a point there at the 85 mil interval or contour. So let's draw that in heavy. We need that, just leave that for now. Okay, then we're going from 65 to 50. We're sloping down. Okay, we've got heights of 90 down to 55. So we're going to be cutting down here again. Okay, so we're going to be using a cut cone. Now, just to make my sketch here again to help me, I'm traveling 65 to 50. So I'm going to be traveling down 15. So using our cutting is 1 is to 1.5. That's going to be 15 down. So that's going to be I'm just using my calculator there. So 22.5. Okay, for our cut cone. Okay, we know that the cut cone goes on the foot, fill cone goes on the heel, so we're cutting, so we're going down here to C, to the foot, to the lower end. So 22.5, okay, hard to do exactly, but we'll get it as close as we can. 22.5 for our cut cone. I'll join that back to B. Okay, and that is 65, so that's at a height of 65. Okay, and we're cutting again, so it's 7.5 meter intervals. So similar to what we did over here. I'm measuring at 7.5. Try and do that perpendicularly. So halfway. 50 and halfway. Let's go. Okay, so I've got my 65, 70, 75, 80, 85, 90. And that's 65, 70, 75, 80, 85, and 90. So that's just about intersecting there. Okay, and just looking here, this is at 65, and right in my measurements here, 65, 70, 75, 80, 85, 90. We've got measurements coming under the 65, so I actually need to measure down. So 65, I need to go to 50. So that'll be my 60, 55, and 50 comes off the page, but I'll just show it here. It's bang on there, let's see, perfect. Okay, so 55, 60, 55 there, 60, 65, 70, 75, 80, 85, 90, 90 again. That actually coming down to 85. So I need to find exactly where they intersect. They don't quite intersect there, so we come down to there. 85. Okay. I'm drawing my curve and my contour. Okay. So that's my cut cone. Now from C to D is level. Okay. We're at a height of 50. All these heights or contour lines are at a lesser height, so we need to be filling up in those areas. So we're using our fill ratio. We're going in 5s, so this way. So our fill cone, we're going up in 5 meter intervals, so we're going to be around 10. Okay. Best I can, let's measure these 90 degrees. 10, 10, 10, 10. That should do us there. So we're at 50 here, so we're going to be going 45, 40, 35, and like the 30, we'll see. Okay, we'll do the same. Ten. Okay, so we're at 50, 45, 40, 35, 30, so we didn't need that last line, and here we're at 50, 45, 40, 35. I shouldn't need a 30 there. Okay, so we're at 50, we're going to 45, we're going to 40, 35, and this side we've got 40, 40, 35, 30, 30, 40, 35. And finally these intersect, so we're down to 40 there. Yeah, that should show an intersection. So and here. Okay, so there are contours done on that, with our cut and our fill. So next part of that question, so I can tick that off. Well done. In the space provided at the top of the map, draw the vertical section or vertical profile through the ski run from line E to F. So we've got line E here to F, the vertical profile through the ski run. And we've got vertical towers, so I'll deal with the vertical towers in a moment. So E is at a height of 65. So let's project up here. He's going to be somewhere around there. F, we've got it there, and we know F is at a height of 50 because it's on this surface between C and D, which is at a height of 50. So it's at that height of 50. F is given to us. And we want to find E, which is at a height of 65 because it's between A and B. So let's measure up 555. So that's 55, 60, 65. So that is E. And they want us to draw the profile, the vertical profile. So I know that B is at 65, C is at 50 as well, so C is going to be there. That's going to be B. So here is the profile. We travel from E 65 to B, which is at 65. Then we're travelling on a sloping surface down to C at the height of 50. And then C is level then off to F at a height of 50. So there is our vertical section of that. Vertical towers constructed at points E and F support steel cables for lift. The cable is 15 meters high and 20 meters high above the ground at point E and F respectively. Okay, so at point E, I'm going to be measuring again here. I'm just going to put in some of these contours now. So we've got 5, 10, 15 above. so 55, 60, 65, 70, 75, 80. Okay, and it's up 15, so that's the height of the tower there. Okay, and at F, it's at a height of 20. So F here, we're on upper height of 20. That's the height of the tower there. Determine the maximum distance or vertical distance between the cable and the ground. Okay, so our cable car, we need to draw it as a straight line. Right there, assuming the cable is a straight line, so we're traveling from here to here. Okay, if we're looking along, I would say the maximum height, right, it's high there, then it gets narrower, then it gets higher, higher, and then it narrows again. So right here at C is probably the highest part. So determine the highest part. I'd say that is it. Are they asking us for in millimeters? No, they're not, but we could always measure that. To use my pen to highlight this. So that's 21. It's 21 meters. Right. Show where that came from. Okay, so that's question B completed. Right, lastly now, on the map we've got P and Q, they're 2 points on the surface of the Earth, so P and Q, they're points on the surface of the Earth. Vertical boreholes at these points reveal top surfaces of the stratum of ore at an altitude of 55 and 35 respectively. Okay. Or sorry, 50 and 35 respectively. So borehole Q is drilled in an easterly direction. So drilled this direction because we got our north, south, east. So we're drilling a borehole from Q in an easterly direction and has an inclination of 55 degrees to the horizontal plane. Has an inclination of 55 degrees to the horizontal plane. That's fine. It reveals the top stratum of ore at an altitude of 30. Okay, so that's just finding another part on the top surface. So we're going to have a plane P, Q, and another point. And in the space provided on the top of the map, draw the elevation of the triangle portion and the top surface of the stratum of ore. Draw the plan of the triangle and determine dip and strike. So let's get that. Triangular surface. So first of all, P. That's our P, extended up, Q, it's extended up, and we know the height of both of those, so P is at a height of 50, Q is at a height of 35, so I need to put in a couple more height lines here. 45, 40, 35, 30. So let's just extend on these height lines. So we've got 45, 40, 35, 30. P is at a height of 50, they told us. That's P. The head wall, sorry, that's the head wall of our borehole P. Q is at a height of 35. So that's our head wall of Q. And they're saying when they drill in an easterly direction, so we've got an easterly direction here being drilled, we're going to get another borehole. So another borehole, it's 30 in altitude, so height 30, and it's drilled in an easterly direction. Okay, so Q is on, like the borehole they start drilling it at a height of 90. So let's find the start of that borehole. Q up here. I have to a few more heights again. 85, 90, 85, 90. That is the start of where Q is drilled. Q is drilled in an easterly direction, so easterly direction, or easterly direction. When we're looking in here at that borehole, we know the true, we can see the true angle of it. Okay, so 55 degrees, we're going to be able to see that 55 degree angle here. So 55 degree borehole. Okay, so that's that other borehole, and 55 degrees reveals the top surface of stratum at an altitude of 30. So as that comes down, it reveals another part of the stratum there at 30. So we've got our plane here now. We'll call that whatever we want to call it. That's point. We'll call it point 1 if we want. Or X. And it's drilled in an easterly direction, so I can drop that down. That is the position of it in plan. Yes, that's that borehole, or that's that plane on the top surface of the stratum. So they want us to, in the space provided at the top of the map, draw the elevation, done, draw the plan, done, and determine the strike and dip. So strike is a level line on the surface, so let's locate that level line and use a marker here. So level line, that's where it intersects that plane. We'll call this point 1, point 1. So on P1 will drop our level line onto that, so that locates our strike. Okay, so our strike. Okay, we want to find the dip, so in order to see the dip we need to see this surface as an edge view, so we're going to look along our strike because our strike is a true length line. So XY line, project out P, Q and the strike, and a 1. And our height then will take off our elevation, so P, Q, that should give us a straight line, which it does. And then that angle that's created is our dip angle. So let's measure that dip angle. And I got that at 33 degrees. Okay, so that is everything that asked in that triangle of dip and plan of the triangle and determine the dip and strike. Correct. Okay, So that is the solution to the geological geometry question on 2013.